So here again the formula. We are going to write down the formula for the acetaldehyde, that is CH3CHO. This is the normal formula that we did, but in the questions they use this formula C2. There are 2 carbons here and there are 4 hydrogen and 1 oxygen. If this formula is given to you in the question, then remember it is acetaldehyde. Okay. This one is structural formula. Structural formula. Also structural formula. Structural formula. So in the structural formula, we are going to write down the structure of both organic compound formaldehyde and acetaldehyde. So let me write it for the acetaldehyde. Acetaldehyde, you can write it. It is very easy. You can take first the alkyl group CH3, extend one line. Take the central carbon here, extend double bond here, the oxygen, then hydrogen. This is one way of writing. Another way of writing it, you can write both the formulas, which will be helpful to you, because in some books you will find in this manner as well. So if it is written in this way or this way, both represents acetaldehyde. Okay. Similarly, for the formaldehyde, the formula is going to be HCOH, same like this, or you can write H here and then double bond here. Both of this formula represents the structural formula of the formaldehyde and acetaldehyde. Write down its molecular mass. Molecular mass, you can calculate and write down its molecular mass. And the molecular mass. Okay, so hypignin. Okay, so hypignin. We are going to write down the hypignin. So since the formaldehyde contains only 1 carbon, so we are going to take the word methane, and here we are going to take the word ethane. Okay, we are going to solve it mathematically. So methane minus E. Okay, we are going to remove the E. Minus E means we are going to remove the E from the word ethane also, E from the word methane also. Then after that, we are going to add the word. You see the word here, Al. Here we are going to add the word Al here. Can you tell me what will be the product name here now? Here it will be methanal, methanol. Here ethanal. We have put mathematically the name.
बड़ा हरामी हो बेटा.
So in the laboratory preparation again, these 2 compounds are prepared in different way. Okay, for here formaldehyde, laboratory preparation of formaldehyde, we use the copper or silver as a catalyst. Okay, and here we use the potassium dichromate as an oxidizing agent. So right here, it is prepared in the presence of copper or silver as a catalyst. 300 degrees Celsius temperature. Prepared in the presence of K2Cr2O7, oxidizing agent. Acidified. Acidified, that means it is acid also present in it. Acidified K2Cr2O7, potassium dichromate. So we are going to see the the reactions now. Okay, so reactions, the manner in which the reaction takes place is almost same because they are going to react with the nascent oxygen. Okay, so I'm going to take now. I have already given you the flow chart how the reaction takes place, general preparation, general methods of preparation of the organic compounds. So you already know that one. You can use that flow chart and tell me. Can you tell me to prepare the aldehyde what should be used here? Alcohol, isn't it? As per the flow chart. So tell me the specified alcohol. Which alcohol? And then which alcohol as well here? Yeah, we are going to use here what alcohol? Methanol. And we are going to use here ethanol. So methanol. I'm going to take methanol CH3OH and then react with the nascent oxygen. And then here the product form is LCHO plus water.
It's time to begin the third lesson.
So how does it happen? Let us see here. Look here, all of you look here. If I take this in the form of structure, then it will be okay. I'm writing the structure of the methanol. This is the structural formula of methanol. Okay, and then I'm going to react with the nascent oxygen. Nascent oxygen and the oxygen molecule is two different
This
things.
nascent oxygen is
Although it's
short-lived and
oxygen,
unstable
but this nascent
and
oxygen
have
is
strong oxidizing property.
so this oxygen and this hydrogen is going to form what? Can you tell me? There are two hydrogen and one oxygen. What is it going to form? It is going to form this water. Okay, and do you see here? This bond is going to shift here and form a double bond. Double bond. So what do you have here? Two hydrogens are here, one carbon, double bond, and one oxygen. So you have that structure. Do you remember the structure that I gave you? H, C, H, and double bond O. This structure is going to be formed from here when it jumps here. So this is nothing but formaldehyde. So you have your methanol changing into methanol. Right on this side. And similarly, okay, before we proceed, let us also write down the reaction for acetaldehyde. We can replicate the idea here. Okay. And by the way, in this reaction, what is necessary that you have to mention is you have to mention copper or silver at a temperature of 300 degrees Celsius. You have compulsory to mention. These are the conditions required when the methanol is changing into methanol. Okay. So sometimes in the exam also, what they give is this reactions will be given to you, and these will not be given. There will be a question mark, and you will be asked what are the conditions necessary for these reactions to take place. And you should know copper or silver as a catalyst, temperature of 300 degrees Celsius. Okay. Okay. Next, listen here. Don't write. I'll give you time to write. Ethanol. We are going to take ethanol. Ethanol is CH3, CH2OH, and then we are going to react with the nascent oxygen, and it is going to happen K2Cr2O7. Acidified is represented like this. In what form? Acidified K2Cr2O7 will write. But in the formula form we write like this: slash H plus means it is in acidified form. That means little amount of acid also added to the K2Cr2O7 to function properly, effectively. Okay. Now in this case also what happens is we are going to get here CH3CHO, that is acetaldehyde, and then you are going to get a molecule of water. So you have the ethanol changing into ethanol. Whenever you see the word OL means alcohol. It came from the word alcohol. See, ALCOHOL, alcohol. Al, aldehyde. Okay, so alcohol to aldehyde. So let us see how it happens. Let me write down the structure of this ethanol. This is the structural formula of ethanol or alcohol. And we have the nascent oxygen. So these hydrogen, see, same. This hydrogen combines with this oxygen, and this will come here, and this is going to form your water. From here, it is going to form ethanol. Okay, see, it is in the same way. The structure here, it is going to form like this CH3. This is CH3, and you have C, and you have H, and then double bond O. That is the ethanol structure. Okay, can you write it? So now in this next reaction we are going to take the ethanol. We are going to take ethanol. This is ethanol and going to react with the oxygen molecule. So since there are two oxygen atoms here in the oxygen molecule, so we have to put here 2 as well. Okay. Similarly, when you are writing for the formaldehyde, when you are reacting with the methanol with the oxygen molecule, necessary to put 2 here because there are 2 oxygen atoms here. And then product form will also be 2 formaldehyde here, 2 formaldehyde. 2 formaldehyde plus, sorry, not formaldehyde, here is acetaldehyde, and 2 molecules of water plus 2H2O. It is same like earlier reaction only, but you just have to put 2 in the front and then replace the nasal with the oxygen. See. Let us see how it is formed. So we are going to take 2 methanol here. So I'm going to write down the structure of the methanol here again. This is a methanol. So there are in total 2 methanols here. So 2 is represented by the 2 structures of the methanol here, and I'm going to take the 2 oxygen as well here. 2 oxygen. Okay, now you can see here, this hydrogen will combine with this oxygen and form 1 molecule of water. Again, this hydrogen will combine with this hydrogen and oxygen will form another molecule of water. So you have 2 molecules of water here. You understand how we got the 2 molecules of water? Then you know that this bond will drop here and form the double bond, drop here and form the double bond, and these 2 are going to combine. Wherever I have not circled, it is out. So therefore, HCH double bond O, HCH double bond O is going to form the 2 molecules. Now I'm going to divide this solution in 2 beaker. Okay, here I'm going to take the acetaldehyde, so that I will divide the acetaldehyde into 2 parts here. Are you getting some smell, pungent smell? So we have the formaldehyde here. Then in one of the formaldehyde, I'm going to add the water, polar solvent. So your polar solvent is water. Meantime, I will also take the acetone. The acetone here represents the non-polar solvent. Water represents the polar solvent. So we are going to do a filling test with the formaldehyde. So in this beaker, I am going to take the formaldehyde. This is the formaldehyde. Okay, formaldehyde. We have a formaldehyde. This I have added the formaldehyde. I have poured the formaldehyde in the beaker. And to the formaldehyde, I am going to add the filling solution to here. We have the filling solution 1 here. So I'm going to add this filling solution 1 and 2. adding the failing solution 1 and 2, you have this blue precipitate formed, and then into this hot water bath. Hot water bath. Hot water bath. We have already, this one is the formaldehyde and that one is the acetaldehyde. Now we are going to see how the aldehyde with Fehling solution here. Fs represents the Fehling solution I have written in a short form. So the reaction is HCOH plus CuO. The chemical formula for the Fehling solution is 2CuO, which is known as cupric oxide. Known as cupric oxide. So now what happens, the reaction in this reaction, there will be 2 copper, and then you have 2 oxygen. One of this oxygen will be added here. Okay, and then this copper will combine with this oxygen, and then it forms the Cu2O, which gives rise to brick red precipitate, which I am going to show you. The name is known as cuprous oxide, plus then you are going to get the formic acid, or also known as methanoic acid. IPAC name is methanoic acid. Methanoic acid. So this is the chemical reaction. This is known as methanol. Okay, our result is ready. You can see the brick red precipitate formed. This brick red precipitate is formed by the Cu2O when the formaldehyde, that is methanol, reacts with the Fehling solution, that is cupric oxide. This brick red precipitate is formed by the cuprous oxide, and there should be a arrow downward to indicate the precipitate is formed. This is acetaldehyde. You can see the brick red precipitate formed in the acetaldehyde also. Okay, there are some changes. The chemical reaction has not taken fully, that's why you cannot see complete change in the color, but still then you can see some brick red precipitate, brick red color change acetaldehyde. We'll see a reaction of acetaldehyde, CS3CHO, with the Fehling solution. Similarly, we have added the Fehling solution A and Fehling solution B to the acetaldehyde. And we have seen the color changes. The chemical reaction is same. We can replicate the same ideas here, copy the same ideas here. We take the acetaldehyde CS3COH and react with the 2CO, which means you have copper, oxygen. All of this oxygen will add here. So active hydrogen, and then these 2 copper will combine with this oxygen. Cuprous oxide, which gives rise to the brick red precipitate. Brick red